Okay, good morning all. Please confirm that the presentation is visible on your screen and put your roll number in the chat box for your attendance. Okay, in today's session, we are going to discuss the testing methods of the plastics. Means how to determine the properties of a given plastic material by conducting the different tests like tensile testing, flexural testing, impact testing, then tensile impact energy testing, then flammability testing, and to determine some electrical properties of that material, we are going to conduct the some electrical properties testing, and at the end we are going to check the quality of that particular component manufactured by performing some quality control inspections on that material. Okay, now I will start within a few minutes. Before that, I will try to summarize the or revise what we have discussed in the last lecture. In last lecture, we have studied the concept of monomer and polymer, and after that, we have discussed the polymerization concept along with its brief classification. And in that, we have studied addition polymerization, condensation polymerization, copolymerization, and one one more type is there. Okay, this I have missed in the last lecture that I will explain in few minutes here. Okay, this is a coordination polymerization. Okay, in the initial slide here. Okay, here four types are there of the polymerization: addition, coordination, condensation, and copolymerization. Except this coordination polymerization, all three types I have discussed in the last session only. Now I will discuss this coordination polymerization. Okay, for this coordination polymerization, I have added this slide here. Okay, in short, this is the example of that. If you are able to see this slide, this is the example of coordination polymerization. Okay, if you are not able to remember it, no problem, just you have to write this one sentence. You can explain this in the one sentence that the polymerization which occurs when we are adding one catalyst or accelerator. Okay, and that catalyst may be in the form of metal salt. Due to addition of that metal salt, it will trigger that process, or it will start the polymerization process, and we will get the polymer. Okay, this process will be termed as the coordination polymerization. Means one you can say that the accelerator you have to add in the form of metal salts, and it will accelerate the process. Monomer will be there, and that monomer will get transformed to the polymer only in presence of that metal salt. Otherwise it does not take participation in the polymerization. Okay, this will be termed as the coordination polymerization. Due to coordination of the coordination of that metal salt, added metal salt, that polymerization process starts. That's why it is termed as the coordination between the that accelerator, or you can say that the catalyst, and that particular monomer is needed here. That's why it is termed as the coordination polymerization. Okay, this is one example I have explained here. Organometallic catalyst is added here in the monomer, and it will get transformed to the polymer. Okay, generally used here we are using the catalyst. Here I have highlighted a few catalysts. titanium, molybdenum, chromium, nickel. These catalysts we are using. With the help of these catalysts only, this transformation will occur. Okay. Now I will move towards the next part. Now, before using any material in the actual practice, you should check what properties are there for that particular material. Depending on their properties only, we can decide the application of that particular plastic material. And here, to check the properties, we are going to conduct certain tests. And only few important tests are there, like tensile testing to determine the tensile strength, and then the flexural test, then impact testing, then tensile impact energy testing. Okay, only these top four tests are important, and remaining these are not included in your syllabus. Just I have mentioned their names. Only first four tests will be there. I will discuss that four tests one by one during this session only. So we will start with the tensile testing. Okay, I have summarized here the what are the why we are conducting the tensile testing. Uh, this part I think you have already studied in the metallurgy subject. So I will explain it with the help of the diagram here. Okay, so this is the basic diagram to determine the tensile strength of a particular plastic material. We are going to conduct the tensile testing, and for conducting this tensile testing, we are going to use the universal testing machine, that is nothing but the UTM. Okay, now on the left side of this slide, you can see the arrangement with the help of that universal testing machine. And it is divided in the two diagrams. The top diagram is universal testing machine. This is the arrangement for conducting your experiment. And whichever changes are there during that particular test in that particular plastic material or test specimen, that I have highlighted here in the next slide. Whatever changes may occur according to the application of the load, there may be changes in their length, there may be changes in their width, you can say that width or diameter of that specimen, that are indicated according to the that load applied. There will be changes in the length of that specimen and diameter of that specimen, that is highlighted here until that component got break. Okay, now this is the tensile testing, and as you are already aware about this, that this tensile testing comes under the category of the destructive testing methods. Means that component may get damaged or destructed at the end. Now here the first step is you have to prepare the specimen. Okay, this is your specimen. You have to prepare that specimen and you have to fix it. Okay, this is the first stage. Now in the second stage, you are going to fix that specimen here. Okay, this diagram, all I'm not going in brief related to the constructional details of that equipment. Okay, all you are aware about it. This Here we are going to fix our specimen. These are the supporting columns here, and with the help of these supporting, or you can say that fixed and moving crosshead, we are going to apply the load. In the first stage, you have to prepare the specimen, and you have to fix that specimen in this particular universal testing machine. Then we are going to in the second stage, gradually we are going to apply the load. Here we are not going to apply the load in the in the one stage. Here we are gradually going to increase the load, and as we are going increasing the load gradually. For that particular load applied, we are going to take the readings for concerned to the change in the length of that particular test specimen. Okay, and this procedure will be repeated until that component gets breaked. Okay, this will be the end stage. It will get broken into two pieces. Okay, and here before the breakage, when I will explain the stages, this is the initial, or your component at the initial stage. Then you have started applying the load. Okay, Now it will get means as we are conducting the tensile test means we are pulling that component from both the sides. Okay, we are pulling the component. Now due to this pulling force, what will happen? The length will start increasing and the diameter will start reducing. Okay, here you can see the changes as force or load is increasing, length of the component increases and diameter will decrease. And here you can say that this step is termed as the neck formation stage. Okay, slowly neck will be formed, and as you continue to increase the load, after some time that component will get breaked. Component will get breaked. The okay, the point of maximum load carrying capacity before the breakage, that will be termed as the ultimate tensile strength. Okay, and at the end, the specimen fractures, and related to that, you have to take the readings. Okay, so whichever this is the you can say that the general tensile testing method. Now, to conduct this test on the plastic material, here we are going to use the ASTM D638 standard. Okay, under this standard, you have to prepare the specimen in the given dimensions only. Okay, in the given dimensions only, you have to prepare the specimen. Okay, like here I have mentioned the dimensions. As per these dimensions, you have to prepare the specimen. Okay. Okay, now here you can say that the specimen you have to prepare, it will be somewhat the if you have seen the some animation movies, you can see that in that dog animation movies will be there. In that there will be a bone, same similar shape, similar kind of shape you have to manufacture here. Okay, under this shape you have going to take the thickness 14 millimeter thickness. Okay, or you can check the dimensions here. Okay, I will try to zoom it if it is not visible, or you can zoom it on your screen only. Okay, these dimensions will be visible. Okay, just you have to remember that these standards used will be ASTM D638 standards. Okay, and under that this specimen will be prepared. And here, for this specific plastic tensile testing method, the time required will be from 30 seconds to 5 minutes. It does not take more time. And in this method, other than the tensile strength, lots of properties can be determined, like toughness of that particular material, okay, toughness, resilience. These properties can also be determined with the help of this testing method only. Okay, so this is the first testing method. You can say that tensile testing method, which we are going to conduct on the plastic material. And for particular plastic materials, we are going to use the standard ASTM D638 standard. And for the under the standard, we are going to use the prepare the specimen with help of the means dimensions as we have shown here in this slide. Okay, now after the tensile testing, the second testing. Okay, uh, now here one more tensile testing I have collected for the plastic having very means very thin plastics having their dimensions or thickness less than 1 millimeter. Okay, for them here this automated tensile machine is there. These new machines are available in the market nowadays that you can use, and these will come under this ASTM D80 882. Okay, if you are not able to remember this, don't write it. Just this is the compulsory. You have to mention the standard compulsory. Okay, try to remember this. And after this is for your extra information. Now I will move towards the second test, that is the flexural test. Okay, here I have collected two diagrams for flexural testing. This is the simple diagram. You can understand it. Here, this green colored is your specimen or your plastic material on which you are going to conduct the test. This is the arrangement, or you can say that we are applying the load. This is the direction of the load, and this is the support on which we are going to rest, or you can say that support or platform on which we are keeping our specimen. Now this flexural testing is conducted. Here the ASTM standard used is D790. Okay. For the tensile testing, here we have used D638, and here we are going to use ASTM D790. Okay, I will wait for a few minutes here for please draw this diagram. I will wait for 1 or 2 minutes here. Please draw this diagram, flexural testing. After that, I will explain it. After 1 minute pause, I will explain it. Please draw this diagram. Please draw the diagram. It shows the flexural testing. Okay, I have written the name in the bracket, and remember that this particular ASTM standard D790, it will be used for plastic materials. Okay, ASTM D790. Okay, ASTM stands for. Can you put the long form for that ASTM? I think already we have discussed this, or already you are aware about these things. I think you may have studied this in strength of material subject or in metallurgy. If someone is aware about this ASTM, please put that in the chat box. Okay, no one is providing a reply. It is American Society for Testing and Materials. Okay, ASTM standard. Okay, and now I will discuss now, as I have given sufficient time to draw the diagram. Now we will discuss how this actual flexural test is conducted. Now, as already I have mentioned that this flexural testing for plastic material, it is carried out under the ASTM D790 standard. Now here in this tensile testing, sorry, in this flexural testing, this specimen, it is prepared in the rectangular shape. Okay, in the rectangular form that specimen is prepared, and that specimen is kept on the two supports. Here you can easily see here, we have kept this rectangular specimen on two supports, and sorry, sorry. And the distance between these two supports is approximately 120 millimeter. Okay, this is a rectangular shaped test specimen put on the two supports, which we are keeping away at a distance. Generally it is 120 millimeter distance away from each other, and we are applying the, we are going to apply here, we are going to apply the load exactly at the center of the specimen. Okay, this load, it should act, or it must act at the center only. Okay, now here we are applying this load at the center only. Now here we are going to check the means we are going to check the strength. In the flexural testing we are going to check the flexural strength, and this flexural strength is nothing but the maximum stress that a particular material can carry at the outer fibers. Okay, maximum stress that can be carried by that particular material at the outer fibers before the failure or before the crackage or before crack occurs. Okay, so this is the flexural testing. Here we are applying the compression force here on the top surface. Okay, one more diagram I have collected here. Okay, here whichever diagram I have collected here, this distance is 120 millimeter. Okay, and this is 64. This is wrong. 120 millimeter will be distance between these two supports. Now please concentrate here. Okay, we are applying the load. Here we are going to apply the load, means this top surface will be subjected to the compression, and at the bottom here the tensile force, you can say that tensile force will act, or it will get pulled from the both ends. In short, you can say that at this top surface compressive deformation will be there, and the bottom surface tensile deformation will be there, and due to that crack will be created here. And in this test we are going to determine the maximum stress that can be carried, or that can be carried by the outer fiber. Okay, the outer fiber of that particular test specimen, or that particular plastic material, that will be termed as the flexural strength. Okay, under this flexural testing we are going to determine the flexural strength of that particular material, and that flexural strength is nothing but the maximum amount of stress that can be carried by that particular material at the outer fiber. Okay, outer fiber before that crack occurs, or the failure of that component, or that plastic material occurs. So this is the flexural testing. Okay, this is the arrangement. Here just correct, you have to make the correction. This distance is 120 millimeter. Okay, at the top surface what is important, we are going to apply the load. It is compressive in nature. The load will be compressive in nature. This top surface will be subjected to the compressive stress, and this bottom surface, or the outer fiber of that particular material, will be subjected to the tensile deformation. Okay, it will get pulled from both the ends. It will get pulled. Due to that, tensile deformation will occur, and a crack will be formed at the outer fiber, and the maximum stress carried by that particular plastic material before that crack occurs, it will be termed as the flexural strength. Okay, in this way we are determining the flexural strength by conducting the flexural testing on that plastic material. And the standard used for conducting this flexural testing is ASTM D790 standard. Here we are using this standard. So this is the second testing which we are conducting on the plastic material. Okay, in first test we have determined its tensile strength by conducting the tensile testing. In the second testing we have conducted here, means how to conduct the flexural testing to determine the flexural strength. Flexural strength is nothing but the maximum amount of stress that the outer fiber can carry before the crack formation or failure. That will be termed as flexural strength. And after this flexural testing, we will move towards the next point here. Okay, this is the impact testing. This is the third is the impact testing. Okay, now here these will be last two testing methods, important testing methods, the impact testing and tensile impact energy testing. Okay, both tests will be similar, just one arrangement will be different, or the fixing of the particular specimen, we are doing it in the different way. That's why different names are given: impact testing and tensile impact energy testing. These two methods will be there. These are last two testing methods for the plastic material. I will wait for a few minutes here. Please draw the arrangement which we are using for conducting the impact testing method. Okay, please draw this arrangement. I will wait for a few minutes here. Please complete the drawing, and after that, I will explain the this how this impact testing is conducted and how the tensile impact energy testing is conducted, and what will be the basic difference between impact testing and tensile impact energy testing. A very small difference will be there. Process will be somewhat same, or you can say that process is almost similar in both the testing method. Just the arrangement of the specimen is in different way, or slight change is there in the specimen fixation method. Okay, please draw this diagram. I will give some time here, wait for one few minutes. After that, I will start the procedure, and we will discuss related to its output. And please complete the drawing here. Okay, this is the arrangement for conducting the impact testing. Okay, this is the base. You can able to see it clearly. This is the base, and the one anvil will be there. On that anvil, we are going to fix the specimen under this test. One hammer will be there. With the help of this hammer only, we are going to add, means we are going to create an impact on this specimen. Okay, means during this procedure, we are going to take the readings related to the starting position of this hammer and end position of this hammer. Okay, and with the help of this indicator, okay, this is one indicator. With the help of this indicator, we will take the readings, or you can say that indirectly it will provide you, means the energy absorbed by that particular material under the test before, okay, prior to the fracture due to the impact created by this hammer. That will be nothing but the, you can say that the toughness of that particular material. Okay, this will be the schematic arrangement here. Please complete the drawing, and those who have joined late, please mention your roll numbers. Okay, now I will check how many students are listening. Roll number 17 is there. Suraj Gaikwad. Roll number 17. If you are not providing reply, I will mark your absentee here. Okay, roll number 17. Roll number 58. Roll number 58 is here. Roll number 58. No one is providing reply. Roll number 10, 10, 11, anyone is here?
Roll number 7. Sorry, sir.
7, okay. Okay, I request all students to write name in proper way, which was instructed by your class coordinator and all staff members. First, you have to mention your division, means class, B division for final year, BB. After that, you have to mention your roll number and then write your name. Okay, it will be helpful for me. Yogesh Raut, are you there? Yogesh Raut.
Yes, sir.
Kindly make the changes in name,
O-
whichever I have told you now. Means you have to mention your division, roll number, and then you have to write the name.
Okay,
All
sir.
students are instructed to make these changes. Okay. Those who have joined late, please mention your roll number in the chat box. I will collect the attendance later. Okay. Now I will move towards the this actual testing. Okay. This in this today's session only, we have to complete this. Only two. These two will be last testing methods. Okay. Now here, now this is the arrangement. I will explain it. This is the arrangement for conducting the impact testing. This will be the base. Here anvil will be present. On that anvil, we are going to fix our test specimen. One hammer will be there. Hammer in some books it is mentioned as a crosshead also. Hammer, crosshead, or a pendulum will be there. This will be helpful for creating the impact on the specimen. And then here one at the top, one indicator will be there. On this indicator, we can measure the starting position and end position of that pendulum or the hammer. Okay, in the first stage, what you have to do before conducting the impact testing, you have to prepare the specimen. Okay, you have to prepare the specimen in the given standard dimensions. Here you can go for the ISOD impact test or CHARP impact test, but generally for the plastic materials we are using the ISOD impact test. Okay, ISOR impact test we are generally using here. Now, what actually we are going to do in this impact testing? Here, actually, we are going to measure the, or we will get the toughness. And how you are, what is the meaning of the toughness here? The amount of energy absorbed by that particular material before the fracture, okay? And due to the impact or after the impact, how much amount of energy that particular material will absorb before it will get breaked or it will get fractured. Okay, and here we are going, generally we are going to use the ISOD impact test, and whichever test specimen we are going to use here, already we have discussed this test in the metallurgy subject, that that particular specimen we are going to create a notch. Okay, one notch will be created, and that specimen prepared will be fixed here, and at a certain, initially this hammer will be at a particular position, and this will be your starting, it will be marked as a starting position, and we are going to check the height of that particular pendulum or hammer. Then after this we are going to release it, and a sudden impact will be created on that specimen, and it will get fractured, and we are going to take the swing position, or you can say that the end position of that particular hammer. Again, its height will be marked and it is measured. Okay, and we are going to check, take the differences between the, simply you can say that whichever potential energy is there at this initial position and at the end position, we are going to take the difference. Simply you can say that we are going to take the difference. This is analytical method. Okay, toughness can be determined with the help of this indicator directly, or with the help of this height, initial height of the pendulum and end height or swing height of the pendulum. You can calculate the initial potential energy and final potential energy, and you can take the difference, and with help of some analytical formulas you can calculate the toughness. Otherwise you can take the help of this indicator, and by using the initial position or starting position of the hammer with the help of this indicator and end position of the hammer and concerned reading on this indicator, you can calculate the toughness, amount of energy absorbed by that particular plastic material due to the impact before the fracture. Okay, this will be the impact testing, and generally ISOD impact testing we are using for checking the toughness of that particular plastic material here. Then after this, the next test is the, I have not collected the separate diagram here for this tensile impact energy testing. Okay, you can say that tensile impact energy testing. Now here, the only small change will be there. Okay, which small change we are making here? Okay, now to determine the tensile impact energy testing, what we are going to do here just we are going to change the position of the specimen with the help of one gripper. With the help of one gripper, we are going to fix the specimen in such a way that it will form a cantilever beam. Okay, it will form a cantilever beam. Cantilever beam will be, one end will be fixed and another end will be free. Okay, another end will be free. This is termed as the you can say that the specimen will be prepared in such a way that, or it will be fixed in such a way that it will form a cantilever beam, and with the help of one gripper we are fixing its one end will be fixed and another end will be free, and on this free end, okay, on this free end we are going to apply the impact with the help of this hammer. Okay, here specimen will be fixed in such a way that, means simply you can say that we are placing it horizontally. In the first impact testing, we are placing it in vertical direction. Okay, specimen will be in vertical direction, and this impact will be created by the pendulum. But in tensile impact energy testing, the specimen will be fixed in horizontal way, and one end will be fixed with the help of gripper or gripper. In that gripper we are fixing the specimen, and another end will be free, means in short it will form a cantilever beam. Okay, it will form a cantilever beam. One end will be free and another end will be fixed, and this hammer impact will be applied with the help of this hammer on the free end. Okay, on the free end means it will get subjected to the tension. Okay, means tension will be created there due to the impact on the free end, as one end is fixed and from other end impact will be created due to the hammer. Tension will get created, and whichever corresponding you can say that reading, or we are getting the energy lost due to that swinging beam, and that will be termed as the impact strength here. Okay, that will be termed as the impact strength, or you can say that tensile impact energy. Tensile impact energy, here we are calculating the energy, potential energy at the initial stage and at the end stage, and we are just measuring the loss in the energy of that particular pendulum or the hammer, and that value will be given as the tensile impact energy. Okay, tensile impact energy. And why it is termed as tensile impact energy? That energy absorbed by that particular material or that test specimen, and here impact is also there, and as that specimen is fixed in the cantilever way or in the form of a cantilever beam, at the free end, due to the impact from that hammer, tension is also created. That's why whichever amount of energy is absorbed by that particular test specimen before the failure, this will be termed as tensile impact energy. Okay, tensile impact energy, and we will be able to measure the impact strength of that particular specimen with the help of tensile impact energy testing. Okay, in this way we have completed four testing methods. Okay, I will summarize this. We have completed the four testing methods. Uh, in this today's session, we have learned, or we have tried to understand how the testing is done on the plastics, and in that particularly we have discussed the how the tensile testing is conducted on the plastic material, and how the flexural testing is conducted, how the impact testing is conducted, and we have learned the how the tensile impact energy testing is conducted. Okay, there are some tests to determine the flammability, some electrical properties of that particular plastic material. Okay, and then some other testing will be there to check the optical properties of that plastic materials. Okay, just you can mention that their names, means these tests were conducted. Okay, flammability test, then temperature measurement test is there, then electrical properties testing, optical properties testing. Okay, importance test will be tensile testing, and this in tensile testing, this will be general stages. It is conducted with the help of UTM. These are the stages, and this will be the testing and materials D638. Okay, and for thin components or thin plastic materials, we are using this ASTM D882. Okay, this is the compulsory. You have to remember this name. You have to mention there. This is for the plastic films having less than 1 millimeter thickness. Then flexural testing we are going to conduct to determine the flexural strength by applying the compressive force. And here we are using this ASTM D790 standard. Okay, this top layer will be subjected to the compressive deformation and bottom layer will be subjected to the tensile deformation. The maximum amount of stress that can be carried by this outer fiber before the crack occurs, that will be termed as flexural strength. Okay, then impact testing. Here impact testing is one method, and just by changing the position of that specimen we are conducting tensile impact energy testing also. Okay, Here in the impact testing, this specimen prepared will be placed vertically, and we are preparing the specimen by using the standards of ISOD test specimen. Okay, ISOD impact test specimen standards. We are creating the notch, and this hammer will be striked, and we are going to check the their initial position and final position, and we are going to calculate the amount of energy absorbed by that specimen before failure. This is the impact testing. And tensile impact testing or tensile impact energy testing, this specimen will be kept in horizontal way, and one end will be fixed in with the help of a gripper, and another will end will remain free in the form of a it will form a cantilever beam. And on the free end, what we are doing, we are applying the impact with the help of this hammer. Okay. Horizontal In the horizontal way, this specimen will be fixed, and one end will be fixed in the gripper and other end will be free, and on free end this hammer will get impacted. Okay. And that failure of the component will occur, and amount of energy that the particular specimen will absorb before the failure. Here, the failure will occur due to the tensile and impact. Okay, due to this impact, tension will get created in the specimen. Okay, that's why this particular amount of energy absorbed, it will be termed as the tensile impact energy. Okay, and we are able to measure the impact strength of this specimen with the help of this impact testing and tensile impact energy testing. Okay, in this way, we have completed the testing methods which we are going to conduct on the plastic materials. In this way, we have completed this part, different testing methods which we are conducting on the plastic materials. If you are having any difficulty, please mention in the chat box. Please, if you are having any difficulty, please mention it, or you can ask me directly also. You can unmute yourself and you can ask me whichever queries are there. We'll try to explain it here only. Okay, one more notice is there. If suppose you have missed any lectures, I have whichever lectures I have conducted, all that lectures video link I have uploaded on the YouTube channel also, and that link is given in your study material sheet. Okay, which I think it will be shared by Kashit sir. You can go through that. Okay, if you are not having any difficulty, I will stop here. Thank you for attending this session.